Question 6, Part C. Coal is extracted from a mine at a rate that is proportional to the amount of coal remaining in the mine. Hence, the amount R remaining after T years is given by R equals R0 times e to the power of negative kt, where k is a constant and R0 is the initial amount of coal. After 20 years, 50% of the initial amount of coal remains. Part 1. Find the value of k. It is not given what the value of R0 is, which represents the initial amount of coal in the mine. Now R is equal to R0 times e to the power of negative kt. What we do know is that after 20 years, whatever the value of R0 is, 50% or half of R0 remains. So R is equal to half of R0 after 20 years. Hence, we can solve for k the equation half of R0 is equal to R0 times e to the power of negative k times 20, where R0 is a positive value. In other words, it's greater than 0. So we can divide both sides of the equation by R0 to eliminate R0. So the equation simplifies to half equals e to the power of negative 20k. Taking the natural logarithm, or the log base e, of both sides of the equation, we get ln of 1 over 2 is equal to negative 20 times k. Now, dividing both sides of the equation by negative 20, which is the coefficient of k, to isolate k, we get k is equal to ln of 1 over 2 divided by negative 20. Now, ln of 1 over 2 can be written as negative ln of 2, and we're dividing that by negative 20. So a negative divided by a negative, of course, gives us a positive. So k is equal to 1 over 20 times ln of 2, which in decimal is a value that's equal to 0.03466, correct to 4 significant figures. Part 2. How many more years will elapse before only 30% of the original amount remains? Solve for t the equation 0.3 R0, which represents 30% of the original amount of coal in the mine, equal to R0 times e to the power of negative kt, where k is equal to 1 over 20 times ln of 2, which is the value of k that we found in part 1. Now, since R0 is positive, we can divide both sides of the equation by R0, similar to the process that we did in part 1, to simplify the equation, and we get 0.3 is equal to e to the power of negative kt. Taking the natural logarithm, or ln, of both sides of the equation, because we need to isolate the t, we get ln of 0.3 is equal to negative kt. Now, to isolate t, we divide ln of 0.3 by negative k. So t is equal to ln of 0.3 divided by negative k. So we get ln of 0.3 divided by, open bracket, negative 1 over 20 times ln of 2, close bracket. And that evaluates to 34.7393 and so on. Now, 34.7393 minus 20 is equal to 14.7393 and so on. We'll round it at the end. So rounding this value to one decimal place, this value here represents the number of years beyond 20 years that will elapse before 30% of the original amount of coal remains. Therefore, 14.7 more years will elapse before only 30% of the original amount remains correct to one decimal place.